Good afternoon everyone. So today we are going to start some more numericals on the mole concept. So before starting this lecture, if you want to ask some questions, you can just ask so that we can discuss those questions. So is there any doubts and something you want to make it clear in this chapter? So let's ask and do this question. Till then, try to do this question, lecture number 9. So try to do this question and ask any question if you have. So try this question. To what volume in ml must 50 ml of 3.5 molar H2SO4 be diluted in order to make 2 molar H2SO4? So it is saying that we have the solution of 50 ml and 3.5 molar H2SO4. So how much water should we add to make this solution 2 molar? So do it. Can you do it? Try this once. Done? Have you tried it? Tried this question? See what is happening. We have this much ml and the molarity is this. Now we have the molarity and we need to find out the volume. So we have the relationship m1v1 equal to m2v2. We have 50 ml and 3.5. and M2 we have 2 molar and V2 volume. So V2 equal to 50 into 3.5 upon 2.10. So 0 and this is divided by 2, it will be 87.5 ml. So this is going to be the volume for this solution. Now let's try to change the question. If question was how much water we need to add, how much water we need to add, can you do it? What will be the answer? What will be the answer? Write in the chat box. If it is asking how much water we need to add rather than the complete volume, so try type your answer in the chat box. Okay, so see how to do it. So what is that if question is changed? So total volume is 87.5 ml and initially it was minus 50 ml. So how much water we need to add? 37.5 ml water need to be added. So is there any doubt in this question? Is there any doubt in this question? Do you have any doubt? Tell me, is there any doubt in this question? Okay, so let's start the second number question. What is the density of oxygen at NTP? Can you do it? Density of oxygen at NTP, O2 and NTP. Try this question and type your answer in the chat box. NTP, the density of oxygen gas at NTP. Okay, so now density. So we have the formula density is equal to dirty PM, and the density will be PM upon RT. So NTP pressure is, let's say, 1 atm, and molar mass equal to 32 gram per mole. R is 0.0821 liter atm per Kelvin per mole, and this temperature is at NTP 25 degrees Celsius plus 273, which is 298 Kelvin. So now you can write pressure 1 atm, 32 gram per mole, 0.0821 liter atm per Kelvin per mole into temperature is 298 Kelvin. So Kelvin to Kelvin cancel, per mole to per mole cancel, atm to atm cancel. So you will get this in gram per liter, which is the density. So try it, tell me the answer, do it, solve this question. Yes, how much? 1.307 gram per liter. So is there any doubt in this question? Is there any doubt? Do you have any doubt? See how this formula arrives. If you forgot, let me tell you the thing how this formula is arrived. If you remember the PV equal to nRT, then PV equal to weight upon molecular weight RT, then pressure is going to be, send this mass here, weight upon volume equal to RT, which is the DRT. So now we have DRT equal to PM. So formula is dirty PM. So dirty PM is the formula. Look into this, and is there any doubt? Okay, so let's see the next question. The weight of oxygen that will react with 1 gram of calcium. So see, calcium solid will react with oxygen gas and it will form calcium oxide. This is half. Okay, so it is saying the weight of oxygen required to react with 1 gram of calcium. So try this question. If you can do it, let me know. Try this. Tell me your answer. Type your answer in the chat box in the numbers what you got. Did you get? Okay, see what you can do. This question can be done by two methods. One is the mole method and another is the principle of atom conservation, POAC, where we have calcium solid, half oxygen gas, and it is giving calcium oxide solid. So you can write the number of moles. 1 gram, 1 divided by 40 mole, and we need to calculate the moles of this. So 1 mole of calcium is going to form the 1 mole of calcium oxide. So 1 by 40 is going to make the 1 by 40 mole of this. 1 mole of this required half mole of this. So 1 by 40 mole of this required 1 by 80 mole of this. 80, not 180, 80 mole of oxygen. Mole of oxygen, which is the weight upon molecular weight. So it is saying the weight of oxygen. So weight will be 1 by 80 and into 32. So 32 by 80. So what will be the answer? Let me know. Tell me the answer. 32 by 80. What is the answer? 0.4 gram. Now do by the principle of atom conservation. Okay, so this is not the POAC, this is the mole concept. This we have done with the mole concept. So this has been done with the mole concept. And let's see the POAC method, how to do with the POAC. So apply POAC on calcium atom. So if you apply the POAC on the calcium atom, so what it will be? It will be 1 number of moles of calcium equal to 1 into number of moles of calcium oxide. Okay, then POAC on oxygen atom. POAC on oxygen atom, what will be it? It will be half number of moles of oxygen equal to 1 into number of moles of calcium oxide. Now this and this is equal, so we can compare the half number of moles of oxygen equal to number of moles of calcium. So this will be half into number of moles. We don't know weight upon molecular weight. Number of moles of calcium is weight upon molecular weight, which is 40. So the ultimately weight will be what? So oops, this is not half, this should be 2. This should be 2 because there we don't care about the stoichiometry in POAC. So this 2 will be here, 2 and 2. So weight will be what? Weight is 32 upon 80, which is in our case also 0.4 gram. So this is how you can do this question by the principle of atom conservation and by the mole concept. Is there any doubt? Any doubt in this question you can ask? So you can see that this question we have done, we can do with the two methods. One is the mole concept, another is the principle of atom conservation. Now next question, calculate the total moles of atoms of each element present in this. So I am just telling you the molecular weight of KClO3 is 125.5 gram. So it is saying that find the mole of oxygen atom, mole of chlorine atom, then mole of potassium atom. Do it. Try it and let me know. So the number of moles of KClO3 is weight upon molecular weight, which is equal to 1 mole. 1 mole. Then mole of oxygen atom. How will you calculate the mole of oxygen atom? So 1 mole of KClO3 has 3 mole of oxygen atom. So 3 mole of oxygen atom. If it is saying the number of atoms, so 3 into Na. Then mole of chlorine atom, 1 mole, it has 1 mole of KCl3 will have 1 mole of chlorine atom. 1 mole of potassium atom will be, there will be 1 mole of potassium atom. So if it is asking the number of atoms, so 1 into Na, and this will be also 1 into Na. So total number of moles for each elements we have calculated, we have done it. So if you have any doubt, just ask me in the chat box. Is there any doubt? Okay, so next question is, calculate the total number of electrons present in 1.6 gram of methane. You need to calculate the total number of electrons present in 1.6 gram of methane. Try it. So I am just letting you know, 1 methane has 6 electron of carbon and 4 electron of hydrogen, so total it has 10 electron. So 1 methane has the 10 electron. Now you need to tell the total number of electrons present in 1.6 gram of methane. Do it. Yes, 10 electron. Now let's have a look into it. Total number of electrons present in 1.6 gram of methane. So number of moles of methane, 1.6 upon 16, which is the 0.1 mole, and the number of methane is 0.1 mole into Na. Total number of electron see, one methane has 10 electron, so this much methane will have 10 multiplied by Na. So this is the Na electrons it will have. It will have Na electrons. So is there any doubt? If you have not understood this question, let me know. Now do this question. This is very good question. It will take time. So try it. What volume of oxygen will be required for the complete combustion of 18.2 liter of propane at NTP? So I am giving you hint. Apply POAC. So propane is something C3H8 reacts with oxygen. It will give carbon dioxide and water. Now do this question and calculate the volume of oxygen which is required. So volume of oxygen which is required. Do it. What volume of oxygen will be required for the complete combustion of 18.2 liter of propane at NTP? So you need to calculate the volume of oxygen will be required to complete combustion. So apply first POAC. I would say write the equation POAC on carbon atom. On carbon atom, write it. Then POAC on oxygen atom. So first for the carbon atom, then oxygen atom, and then of course POAC on hydrogen atom. Can you do it? Write for these three equations. Write the POAC for all these three atoms. Firstly, I am giving you a hint. Do it. Okay. Okay, so let me write for the carbon atom. If you have written, just match your answer. 3 carbon into number of moles of propane equal to 1 into number of moles of carbon dioxide. For oxygen atom, oxygen is here, here, here. So 2 into number of moles of oxygen atom equal to 2 into number of moles of carbon dioxide plus 1 into number of moles of water. Now we need to find the relationship between volume of oxygen and the data given for the propane. So we need to find the relation oxygen and propane. So if we apply for the water hydrogen atom, so for the hydrogen atom it will be 8 into number of moles of propane equal to 2 into number of moles of water. So see, now here we have 1 mole of number of carbon dioxide, and this relationship we have number of moles of carbon dioxide, so we can put it here. So it will be 2 into number of moles of oxygen equal to 2 into 3, 6 into number of moles of propane, plus we have the 1 water molecule. So just this equation you will have 4 number of moles of propane equal to NH2O. So 4 number of moles of propane, 4 number of moles of propane. So it will be total 10 C3H8 and 2 into number of moles of oxygen. So number of moles of oxygen equal to 5 into number of moles of propane. So see, we got the equation. Can you do it now? This equation we got. Now can you do this question further? Okay, so let's see what is the answer, what you need to do. So number of moles will be what? Volume of oxygen upon 22.4 liter, 5 volume of C3H8 upon 22.4 liter. So this is gonna be cancelled out. So volume of oxygen equal to 5 into volume of C3H8. So volume of C3H8 is 18.2. So this will be 91.0 liter. So this is the oxygen volume we required. We require 5 times of this. So this is something, because the number of moles, the formula of number of moles is volume given upon 22.4 liter, because 1 mole of gas contains 22.4 liter of what? Gas. Done? Is there any doubt? Look into this question again, and is there any doubt in this question? Tell me if you have any doubt in this question. Okay, so let me give you one question. I want you to all do. Question is very simple. N2, 2 ammonia, 2 nitrogen, nitrogen plus 3 hydrogen giving 2 ammonia, and it is given 34 gram. So question is find the number of moles of hydrogen required for this reaction to be happen. So how many number of moles of hydrogen will be required? Can you do it? So is it done? See how to do it. Very simply. So we can write ammonia and hydrogen. So 2 mole of ammonia is going to be formed by 3 mole of hydrogen. So 1 mole of ammonia is going to make by 3 by 2 mole of hydrogen. So how much mole is this? 34 upon 17, which is equal to 2 mole. So we need to make 2 mole. So 2 mole require 3 mole of hydrogen. So how much hydrogen we require? We require 3 mole of hydrogen. If it is saying the weight, so number of moles equal to weight upon molecular weight. So weight is 3 into 2, which is equal to 6 gram. So 6 gram weight we require for the hydrogen. Okay, so this is something you need to do, and this is, I would say, the last question for today. If you have any doubt till what we have discussed, so we have discussed a very good question from the POAC, and then little bit small concept, atoms, and this is the, of course, based on the POAC, principle of atom conservation. You can do by the both method, and I would suggest to all of you, do this question with the mole concept. You need to balance the reaction, of course, and then try it with the mole concept. That is also possible of doing this question with the mole concept. I would be happy if you try it with the mole concept. Okay, so and then we have seen this NTP dirty PM formula, and this is of course based on the molarity. So which is the molarity equation, M1V1 equal to M2V2. So this is what the recap for the today. Is there any doubt? You can just type it, and thank you very much and stay safe. Best of luck.